sort the AV guys at the back of the room out then. Welcome to talk number 2 here in the command room. I'd like to introduce Chadi Ghosn from Turner & Townsend, and he's going to be talking about prompt engineering, chat with confidence, and build AI solutions. Chadi moved to the UK in 2019 and has a Bachelor of Administration graduate. He got into data science in 2021 and is currently completing a data science master degree. He's an enthusiast and really enjoys what he's doing. A round of applause for Ghosy, please.
Hey everyone, welcome to the session about prompt engineering. First of all, my name is Chadi Ghosn. I'm a principal consultant with Turner & Townsend. So first things first is what we're talking about. So prompt engineering is a topic that we take lightly. So we just go into ChatGPT or Copilot and we start asking it questions. But there is basically an art for that, right? So even now, there's jobs called prompt engineering. First of all, before we dive into prompt engineering, let's talk briefly about the disadvantages of a large language model. So first of all, there are kind of 4 main disadvantages for a large language model. The first one is the biased information. So it says that if the data used to train the model is biased, then this will be replicated into the answer, which means the model can learn and repeat these biases. This can lead to unfair outputs. So the second one is hallucinations. So sometimes if the model can make up information that isn't based on its training data. This can lead to incorrect or misleading information, specifically if it doesn't have enough training data in its whilst it's training. The third one is the lack of contextual understanding. So the model can generate text that sounds human-like, but it doesn't truly understand the meaning like humans do. So this can lead to responses that are correct, but don't make any sense. And finally, difficulty in controlling outputs, and this is what we're going to be trying to handle today. So it can be hard to control what the model generates. It might create content that is inappropriate or offensive, even if there are safeguards in place. Now, what is prompt engineering? So first of all, it's the process of designing a prompt to maximize the performance of the AI models and the large language models. It involves creating specific, clear, and well-structured prompts that provide context for generating accurate and relevant responses. It can help improve model performance, mitigate bias, and enhance interpretability, and ensure responsible use of AI. So first things first is what are the general elements of a prompt? First of all, we have the instruction. So this refers to a particular task or directive that you wish the model to do. We have the context. So this supplementary information or added context can guide the model towards improved responses. We have the input data. So this is the input or query for which we are seeking a response. And finally, the output indicator. So it signifies the kind of format of the output. Now, I have a quick example over here saying that I need to act as a Power BI and DAX expert. And then I need help writing a DAX query, explain what is a cross-filter function in DAX, keep your explanation brief, and provide an example. So by just saying these 4 sentences, I was able to get a proper information with an example and everything outlined. Now, as well, there's something called a system message. We're going to talk about it. But as well, I can, for example, ask the model to provide its response in very simple English terms. Or I can even say, explain it to me like I'm a 10-year-old. So all of these kind of terms and keywords can differentiate and have a different response from the large language model. So first things first, and the most important thing is clear instructions. So we have a do and don't. So basically, the don't is just give an overview or vague kind of prompt, which is write a product description in 1 sentence of a water bottle. So the response could be anything. Whilst when we give it some examples or some more detailed information, for example, for a water bottle that is 100% recycled, come with no dyes, and each purchase of that bottle removes 10 pounds of plastic waste, then the answer is much more specific to what I'm looking for. Now, specifying the desired length of the output. So you can tell the model to create responses to a certain size. Now, the amount of words is not very specific, but we can ask it, for example, for amount of sentences, amount of paragraphs, Nonetheless, asking for an exact, might not be very accurate, as mentioned, and it's more reliable to ask for a specific number of paragraphs or bullet points. And we have a couple of examples as well. So summarize the text in about 50 words, summarize the text in 2 paragraphs, and then in 3 bullet points. So I'm not going to go into depth into these different techniques of prompt engineering just for the sake of time, but I just wanted to show you that the amount of techniques that we have. From chain of thought, we have something called complexity-based prompting, so shows up that prompts with higher reasoning complexity, chains with more reasoning steps. So we start asking the question to basically try to get to an answer, not basically just ask it for an answer. We have as well more of them, so we have tree of thought prompting, we have directional stimulus prompting, using gradient descent to search for prompts, and prompt injection. Okay, so now we have use of section markers. A useful technique for formatting instruction is using the section markers. So for example, either it's the triple double quotes, or the hashtag sign, or the minus sign. By placing instructions within these tags, at the beginning or the end of the prompt, the model can more easily distinguish them from the actual content. So this approach helps improve clarity and ensures the model understands our ask. The quick example I have is translate the text into French. Section marker, what's the weather going to be like today? Section marker. So it's how we're structuring the prompt to get the best answer out of the model. So we have as well 2 things. We have something called primary content, and we have something called supportive content. So primary content in a prompt refers to the main subject, like a sentence or an article that is the focus of the query. It's typically placed at the beginning or end of the prompt, enclosed with the section markers. So this approach helps the model to understand the purpose and context of the primary content. So in my example, I have an email from like a generic kind of university email. It mentions webinars, dates, it mentions updates about the university, as well as assignment dates. So the ask was extract the key points from the above email. The 3 key points that I got are university updates, AI webinars, and assignment deadlines. Now, if I add into this prompt something called the supportive content. So the supporting content is basically the things that I'm really interested in. So it includes the supplementary information that can impact the response, but is not the focus. So it consists of details like names, preferences, and future dates. So in this example as well, I've just added 1 supporting content, which is topics I'm very interested in, AI, webinar dates, and submission deadlines. So I did not mention university updates. And we can see the difference in the output of the model. So I saw AI webinars, and then assignment deadlines. So these are the 2 kind of information that I got based on the supporting content that I provided for the model. So cues. Cues in a prompt are guiding words or phrases that assist the model in generating the response. While cues are often used in conjunction with instructions, they can also be used independently. And they're especially useful when prompting the model for code generation. Now, as you can see over here, I just created a quick example. Write a join query to get customers' names with purchases in the past 30 days between tables named orders and customers on customer ID. And then I gave it the keyword, which is the select. And this is how we start kind of a SQL query. So this is how it was able to give me an example of a SQL statement. So request output composition. Defining the output structure in a prompt plays a crucial role in determining the outcomes. So by providing clear instructions, such as requesting citations, specifying formatting as an email or SQL query, or organizing sentiment classification, we can influence the model to generate the responses. This allows it to tailor the results to meet your specific needs and achieve the desired format and structure of the output. So if we look at the example, I've said, so put 2 fictional characters into JSON of the following format. I've specified the format of the JSON file, but it was able to pick up the format that I specified, and it was able to populate it with 2 fictional characters. OK, now for the system message. So the system message is a very important part of the prompt. So in our example over here, it's specifying how I want the model to act as. This message is included at the beginning of a prompt and is designed to give the model instructions, perspective to answer from, or other information helpful to guide the model's response. The system message might include tone or personality topics that shouldn't be included, or specifics like formatting of how to answer. So in my example over here, I said, when I ask for help to write something, you will reply with an answer that contains at least one joke or playful comment in every paragraph. I put a section marker, and then I ask, what is the difference between data warehouse and data lake? So as we can see, I've just highlighted the kind of playful comments that it added. So hoarder's dream, where everything is kept just in case. For data lake, it's like a giant mystery box. You never know what you're going to get. If data lakes are hoarders, data warehouses are neat freaks. So whether you're a hoarder or neat freak, there's a data storage system for you. So it's just how about we're creating that system message, how we're asking the model to respond, and we're going to get a lot out of it. So we have something called zero-shot learning, and we have something called few-shot learning. So zero-shot learning is when we're just asking the model a question, and we're expecting an answer out of it. So there is no specific kind of output for it. But the few-shot learning is when I'm providing examples for the model, and I'm expecting the model to actually pick up the example and then give me the answer for it. So by providing the model with these examples, it learns how to generate appropriate responses based on the given context. And in my example, I used more or less of a sentiment analysis. So I said, please look at the following examples and create a similar output of the following. Do not add any explanation or intro or details. This is awesome, positive. This is bad, negative. Wow, that movie was rad, positive. And then a section marker. And then I gave it my prompt, which is, what a horrible show. And it was able to give me the sentiment analysis for it. So what a horrible show, negative. So it was able to learn from the examples that I provided and then give me the output for it. OK, so breakdown of a complex task. So this is a very important kind of topic, because if we give the model just some information, not everything, and not detailed, we're not going to get an informative kind of answer. So in the question over here, we said Doug can write down the zip line in 30 seconds and takes 5 minutes to climb back up to the top. How many times can Doug ride the zip line? In 17 minutes. So based on that sentence alone, the model was able to give me an answer, although it wasn't true. So it said, so Doug can ride the zip line 3 times in 17 minutes. Now, to be able to think about this systematically, I had to rewrite my prompt, but I had to write in very kind of step-by-step way. So the example here, we just formatted this prompt into something more complex. So Doug wants to ride a zip line. Doug can ride down the zip line in 30 seconds. Doug takes 5 minutes to climb back up to the top. Doug's starting point is at the top of the zip line. Doug's cycle can finish at the top or bottom of the zip line. And how many times can Doug ride the zip line in 17 minutes? So after providing all of these kind of details, it was able to calculate the exact amount that Doug can actually ride the zip line, which is, in fact, 4 times. So 3 full cycles and 1 additional ride down. So we can see that how the prompt is actually created, it affects even the output out of it. So the first one gave us a wrong output, but when we actually broke it down, we were able to get the correct answer out of it. All right, now for the chain of thought. So requesting the model to provide a detailed explanation of the step-by-step process it is used to arrive at its response is an effective method to gain insights into interpretation of the prompt. So it allows you to identify any incorrect logical decisions made by the model, and it helps you refine your prompt to be able to get the desired output. By understanding the model's reasoning process, you can make informed adjustment to improve its accuracy and avoid potential pitfalls. So the example here is, first of all, we gave it a generic kind of model, prompt. We said, what one sport is easiest to learn but the hardest to master? So it was able to actually give me an example, which is the golf, and it gave me some explanation on why it said so. But when I changed my prompt a bit, and I said, what one sport is easiest to learn but hardest to master, and I gave it an extra kind of sentence, which is give a step-by-step approach of your thoughts ending in your answer. So that kind of sentence that I added, it was able to initiate the chain of thought command, and it detailed for me how it got to the answer of golf. So it started by identify the question, consider the criteria, evaluate different sports, finally choose a sport and give the answer. All right. Now to a more kind of advanced topic. So we have something called RAG applications, so Retrieval Augmented Generation Application. Now, first things first, a RAG application is a system that enhances the capabilities of a large language model by adding an information retrieval system. So this allows the application to use specific data to provide more accurate and contextually relevant responses. And what do I mean by that? So first of all, when ChatGPT was released, it took a lot of time, a lot of effort, a lot of money to be able to train that model on the vast amount of data available on the internet. So once they released that model, they cannot every single time or every couple of months when they release new stuff to just retrain, because it's going to use a lot of money, a lot of resources. It's not efficient. So what they did is they created the RAG architecture. So what RAG does is basically that it takes the extra information on the internet. So let's say up until now, the GPT 3.5, it was trained up until the end of 2021. So all the information that is from the start of 2022 onwards are embedded within the ChatGPT model or large language model through a RAG architecture, which means that when you ask the model a question, first of all, it looks at the most relevant information from its data set, which is from the start of 2022. And then if it doesn't find the data, it will try to look somewhere else. Same concept for a document analyzer. So in a website that you can upload your document and start asking questions about your document, that as well is a RAG architecture. So it takes the information of the document and it takes it as the base to answer your questions, but at the same time as well, it can access the training data set to be able to provide you with a context. Now, we have something called naive RAG and we have something called advanced RAG. So the main differences between a naive RAG and advanced RAG is the help and support provided to the user. Now, in a naive RAG, so first of all, we have the user, he sends in a prompt. So this prompt goes through a framework. So the framework is basically, we have something called natural language processing. So it cleans the prompt, basically. It changed the words into embeddings, into codes. And then this embedding goes to something called a vector database, where all of the data is placed. It will try to find the nearest kind of information closest to the prompt that you have. It will then take it back to a large language model and then provide you with the answer. This is a naive RAG. This is how it usually works. An advanced RAG is where we, as a developer, would be able to support the user whilst he's writing a prompt. So we have something called query routing, query rewriting, and query expansion. So this happens when the user sends in a prompt to the framework, and when the framework launches, during that framework, we use specific libraries that would rewrite the prompt of a user in a more kind of detailed way. So it uses these three kind of topics that I mentioned, so query routing, query rewriting, and expansion, to be able to get a more reliable answer out of the model. I'm going to be talking about these three in a second. So this is the main difference between a naive RAG and an advanced RAG. So the advanced RAG, so prompt power and support. So these three kind of things. So first of all, the query routing. So it's the process of directing a user's query to the most relevant information source of database. So for example, if a user asks a question about Python programming, the query routing process might direct this query to a database of programming documentation or a collection of Python-related texts. And this as well happens when we index the data. So it would be able to go and get the relevant indexes, the relevant information. So query rewriting, this involves modifying the original user query to improve the retrieval of relevant information. So the example is, if my question is, what's the tallest mountain? The query could be rewritten as, which is the highest peak in the world? So to better match the phrasing used in the data source. And finally, the query expansion, or the augmented query. This is a technique used to improve the performance by adding more terms to the user's original query. So the example here is, it gets synonyms, related words, or other terms that are likely to appear in relevant documents. For example, if the user's original query are symptoms of flu, an expanded query might be symptoms of influenza virus infection. So these three techniques would improve the prompt of a user from the front end that he's trying to type in to the back end to get you more relevant responses. Okay, so we have some demos right now. So now we looked at how prompt engineering is used in the front end, but we're going to talk briefly about how we use it in the back end. Okay, so first of all, this is an example of a generative AI application. This is called Teaching Assistant. So the whole kind of purpose of this application is that you specify what kind of topic you want to learn. And then if you're a beginner, you're intermediate or advanced in that topic, and it will be able to give you a learning path for you where it provides information, resources, links, tests, use cases, everything like that. So I'm going to put in as an example that I want to learn Microsoft Power BI. And let's say I am a beginner in Power BI, and then I click Submit. Okay, so we're going to see in a second a specific learning path for Power BI. So as we can see over here, we have basics, so introduction to Microsoft Power BI. I have resources, I have example, I have use case. Connecting to data source, same, so creating visualization. And then I have the intermediate level, data modeling and transformation, creating relationship between tables, creating calculated measures and columns. And then I have the advanced, which is Power BI service and collaboration, advanced data modeling and analysis, and data security and governance. And so we cannot control every single time how the model is going to answer, but as long as we know or we push our prompt engineering to the next level, we can narrow down the possibilities of how the model is answering. Okay, quick question. How many lines of code do you think this application took? Just shout numbers. 13, 14. Okay, 110. Okay, so it's more or less true, so it's 54. So it's not a complex application, but it's just the fact of how we're writing the prompt in the backend. So the example here is that I basically just defined a function. This is the main kind of function for connecting to an API of OpenAI. So the model that I'm connected to is the 3.5. Now, the system message that I wrote is the main kind of driver of my application. So I said you are a teacher assistant and you will help create a learning path in any given subject. You will split the output in 3 main parts, basics, intermediate, and advanced. For each part, you will provide points to focus on, and for every point, you will provide a link for a free online resource. You will provide a detailed and elaborate example for every point mentioned. You will provide some use cases, exercises, and tests whenever possible for each level provided, and make sure that all of the links provided are highly reviewed and used by users. So all of the rest is literally just me giving a bit of front end on Streamlit. So that system message was able to generate this learning path that I just showed you. So we just need to know the importance of prompt engineering. Now, so for the second example, I have transcription analyzer. So basically, when you jump on a Teams call and then you record your meeting, you can download this transcription through a Microsoft Word document. So over here, I have an example of a meeting transcription that I have. So I'll just open it and then let it run. So this was a quick call between myself and my colleague. So it was able to give me the people on the call, action items for each person, deadlines mentioned, and then other considerations. So this kind of application has a bit more lines of code, I would say, in the back end, but not much. So let me show you. So in this example, I used few-shot learning. So with few-shot learning, as you remember, so we said that we're going to give it an example. We give an example for the model, how we would like it to answer, and then we expect the model to learn from it and then answer the same. So first of all, I've created the system message. So if you need to, I needed to act as an assistant and note taker and analyze the transcription provided to you, Give me a bullet point list of action for each person based on the mentioned actionable points throughout the document. The names involved in the transcription are only stated after the timestamps as, and I gave it an example. Add any information deemed necessary in the meeting minutes, such as upcoming events mentioned, deadlines when specific month or dates are mentioned, predecessors or successors, and be as detailed as possible, stating all of the needed information. If user 1 assigns a task to user 2, put the action item under user 2's name. So then I gave it just a more or less of an example or a part of a meeting transcription that I had. Of course, I anonymized it just to make sure that it doesn't look for specific names. And then I gave it an example of how I wanted to answer. So I gave it the structure by putting meeting minutes, people on the call, user 1, user 2. I gave it some examples. And then at the end, I have my prompt, which is the transcription that I provided. So when all of this happened, it was able to take that example, it was able to learn how the output structure is, and then it was able to provide the information back to me. Amazing. I think we're on time. Any questions?
Okay, we'll start over here, this gentleman.
Hi, thank you for that. I'm doing a sort of similar application to what you just showed. I have a problem that the model hallucinates. Basically, it uses the test examples and then outputs them as the actual output. I don't know how to get away from that, basically.
Okay, and what is the temperature that you're using of the model? Is it creative? Is it 1 or 2?
That's a good question. I haven't done anything that advanced, to be honest. I haven't used temperature.
Okay, so this is very important. So the model temperature in an API call, it specifies how the model is trying to act. So a 0 is the most precise, and 2 is very creative. If you specify that the model is like 0 or 0.1, this won't actually hallucinate. It will, if it doesn't have the information, it will just tell you that I don't have this information with me. Such as, for example, Copilot, you have moderate, you have creative, and you have precise. So if you click on the creative kind of mode, you might get some hallucinations, but the precise one you won't. So try dabbling a bit with the variables that you can send to the API.
Any more questions?
Hi.
Hi.
Hope you can hear me.
Yeah.
I saw that the prompt engineer you put over there, and I noticed quite a few things that different models respond in different way with the prompt engineering. I also noticed that some of the words you use are very specific, like only, for example, was capital, or do not instead of don't. So how would you tell from the model how best formatting, what path to take and everything? Because I've been experimenting and I took like a month, try to do some prompt engineering that actually worked.
Yeah.
And it was like very painful process.
Yeah. To be honest, it took me a while because it's a lot of trial and error. So you need to just make sure what works for your model. So it's very similar to the agents. So right now, when you're trying to create an agent, the normal prompt engineering for a model wouldn't work for an agent. So it's very specific on how it acts, right? So just make sure that you try a lot of different things. Try to be creative as well with the things that you're trying to experiment with, and you'll 100% find a specific way to be able to get your model to act.
Thank you. Can you hear me? Oh,
yeah.
Okay. Yep. Yeah. Thank you for the talk. Very interesting.
Thank you.
I have a kind of like a bit more advanced question in the sense that I've set up something similar to you, but then there is some argument about how do we keep testing and improving the prompting, and I was wondering how do you sort of like keep track of the evolution, or the probably a similar question, but how do you keep track of the evolution of the prompt?
Okay, so I'm sure you know that there's something called RLHF, which is how you basically you retrain the model based on human feedback, right? So every now and then, you'll have to create a RLHF kind of process where all of the answers that is going out of the model is tested by experts and looked at by experts. Now, even for the most advanced kind of Gen AI creators, there is always room for mistake. I'm not sure if you've guys heard, so it happened with DPD. So there's a chat, the DPD chat, for example, they asked it like, DPD is a very, very bad kind of company. What do you suggest on the DPD website? And it just said, yeah, DPD is the worst provider, worst company ever. I suggest using other companies. So there are things that you can. So within the variables of an API call, there is stop reasons. There are a lot of variables that you can add in, how or when you can trigger the stop of the model. Although the prompt engineering is very important, but it can, to a certain point, be overridden for now. So they did identify all of these kind of issues, and there's a lot of work going on around it. You can control it to a certain point, but there's always someone trying to break it, right? That's the pain point over here.
Yeah, totally agree with that.
Amazing.
Hi, thank
Hi.
you so much for this talk. It's been really, really interesting.
Thank you.
I like that you had quite a broad range of techniques in the talk, but I was just curious, have you done any experimentation with using other LLMs to evaluate the prompts and things that you have, like sort of as a proof case?
Yeah. So basically, I did use some local models. So I tried it on Gemma. I tried it on a couple of models, to be honest. I don't remember on top of my head which are these what kind of models these are. But I can tell you that I had to do a lot of trial and error because not all of the models, they're going to answer the same. So it all depends on how many parameters they have. It all depends on if it's running locally or not. It depends on even the API call, if you're trying to do an API call to the model. So all of these kind of things, they affect these kind of these models. At the same time, so for example, I'm not sure if you're familiar with LangChain. So LangChain for development, I wouldn't use it for production, but for development, you'd be able to, to a certain point, fix your prompt for a specific use case. But it doesn't change based on models, because I'm sure you know that the whole kind of application, it doesn't use a large language model up until the end. So we have the data that is in a vector database. So the prompt goes through embedding to a vector database, k-nearest neighbor gets the similarity, and then once it have these kind of similarities, it ranks them, and then the top one answer, this one runs through the large language model. So all of that is trial and error. That's the main thing that I learned from this, to be honest.
Yeah, it's an ongoing journey, I think we all have.
Yeah, 100%, 100%.
Thank you.
Thank you.
Any more questions?
Thank you. I've been working on a small project on text to SQL, and I trained a model and...
Sorry, can you raise your voice a bit, please?
Okay. Is it fine?
Yes,
Okay.
yes.
I've been working on a project on text to SQL. I trained the model, and the thing I notice when I'm using a simple prompt, because in the beginning you said that if you have more precise prompt, the better answer will be. And when I give like very simple prompt saying translate text to SQL, performance is very high. But when I say having this question and having this schema of the data set, translate or generate SQL, performance decreased. I don't understand how it works. Can you explain how it's connected?
Yeah, to be honest, I can to a certain point explain how this works. So when you have a lot of training data set for that specific example, leaving the model to give you the output is to a certain point good. So this goes back to kind of some machine learning concepts. So we have underfitting and overfitting. So sometimes when you have enough data, if you put more data into it, that becomes overfitting. But at the same time, you can still build a prompt, but it just needs a lot of trial and error. So it's just how you're trying to be able to provide the information. So try using system message, try few-shot learning. Few-shot learning, to be honest, for this kind of example works best, because if you give it a couple of examples, that's gonna just keep on the output structure, right? So yeah, that's kind of the analysis behind that, to be honest.
Thank you.
Thank you. Oh.
Testing. Hello. All right.
Yeah.
So yeah, you talked about the RAG architecture.
Yeah.
And I know that with ChatGPT or LLMs, they're usually not very good at math expressions or getting the calculations correct. So is there a way to have it linked with something like Wolfram Alpha that does specialize in mathematical operations?
Yeah, good question. So to be honest, the large language models are specifically for texts, right? At the end of the day, it's always trying to transform any kind of training data set or prompt into embeddings, into codes, and then putting that into a vector database and generating text, right? Even if you put, for example, for a GPT 3.5, 56.7 times 4.2, it's not going to give you the correct answer. So this is where we introduce coding agents in the backend. At the end of the day, you're trying to use Copilot for something specific, but Copilot or ChatGPT are very generic. So it's trying to answer the wide range of users, right? So if you need something that specific, you'll have to build something custom. And by doing that, I just mentioned LangChain, because I've been working with it and experimenting. So with LangChain, you can add kind of agents that are specific to math. So by doing that, you're going to be able to get much better answers when you're trying to do finance or math or these kind of equations. All right, so it's just about building that kind of custom application.
So is LangChain separate from the RAG architecture?
So LangChain is part of the RAG architecture. So it's how you build a proper kind of RAG, okay, RAG architecture. Throughout LangChain, there are different types of coding agents. And then you can specify which agents you want to add. So LangChain's kind of point of force as well is that inside of it, it can create more or less of multiple models within it to be able to achieve the best out of it. Okay, so it depends on your kind of requirements to be able to get or create the best RAG architecture for the application that you're looking at. All right, thank you.
Hi.
Hi.
Thank you for the wonderful session.
Thank you.
So I've had similar build similar concepts like what you have just shown. I've even tried to build it on using OpenAI API keys and also using try to build the local models. So when I try to build them on a very local basis, like let's say using an Olama, I encountered a lot of the prompts are. The model usually takes these prompts and hallucinates a lot. So have you encountered this? And if you do, what suggestions would you give to get it resolved?
So first of all, the Olama that you're running, is it the 2 billion parameters, 7 billion parameters? Are you running it on which kind of system?
Two, and it's on a normal working laptop, let's say a normal, Mac.
Normal workstation,
Yeah.
okay.
Yeah.
Do you have kind of a custom application built around it, or is it just the kind of Olama? You're just running it on CMD?
Just on Olama.
Okay, so these local models, they do have kind of disadvantages, right? You need to be able to get the best out of them. You need to build a RAG architecture to a certain point on it, right? Even prompt engineering on these kind of models are a bit tricky. I would definitely suggest, to be honest, because I don't use these kind of models because of these disadvantages. So I would really suggest building a small RAG kind of architecture for the sake of, first of all, having more updated information. Second of all, being able to prompt more easily. And if you can run the 7B, it's better as well just for the sake of the output of the model.
Thank you.
Thank you.
Hi.
Okay. Yeah, so my question is around using simple or complex prompts right? And based on your response to a question, so is it suffice to say that there is no golden rule? You can always do a trial and error, try the simple one, try the complex one. Is that what you're saying?
100%. So all of these kind of information that I just shared with you are best practices to be able to guide the model. But this is why I did not show like one complete prompt, because it's always different based on the requirement that you're trying to achieve. So it's just about once you define your the requirement that you need, you can take all of this information and start your trial and error kind of process to be able to achieve the best prompt for your requirements.
So how can you tell which one gives the correct result based on the particular slide you showed about how long will it take you to get from the top to the bottom? So how can you tell, is it the simple prompt that gave you the correct response or the complex prompt?
So this is where what you, so for example, in a normal kind of data pipeline, right? We do unit testing, we do system integrations testing. So out of these two, we know what the input of the data is, and we know what the output is. And what we do is we compare them just to make sure that the input is the same as the output, right? So for this, it's the same. So you give it examples that you know the answer of, and you need to check this by reinforced learning through human feedback. So you need to check that these kind of outputs, these kind of information are correct. You can even ask it, for example, if you're building a RAG application and you're building a document analyzer, you can ask it to provide the referencing. So from which part of the document that you provided, it's getting its information from. So all of those would help you actually validate the information and the responses that you're getting out of the model. So it's just about doing a lot of testing on things that you know, and once you're confident about that it's providing all of this correct information, you can start dabbling with new things and then cross-referencing. So there is a big process to be honest, to be able to do all of that. It's just about taking the right time to be able to achieve it. Thank you. Oh, hi.
Hi, Chadi. Thank you for the examples.
Thank you.
Can you give an example for like the stop that you mentioned, particularly like if the context is, say, a student learning like A-level geography? I want to make sure that whatever they're inputting, like say if they start talking about a different subject, I want to be able to highlight that and make sure that the feedback is not going to then talk about that or give a feedback on that subject.
To be honest, off the top of my head, I cannot provide a specific example like that. I haven't kind of looked at things like that, but an example that people usually use is using profanity or using rough languages in the large language model. So this could be a stop kind of trigger, right? So once someone uses this kind of language, it would prompt the large language model to stop, not to answer on this. So there's a lot of different things that could trigger this kind of stop. It's just about looking at what is available on the large language model, right? So you need to search kind of what are these stop triggers, and then try to be able to, do a specific search for your use case.
Is there an area that I can research?
It's, to be honest, the OpenAI website has a lot of documentation on that as well. Specifically when you go to the API section of the documentation, so it talks about all of the variables to get an API request, and then what are the details of this.
Thank you.
No worries.
Okay. Hello. Ooh, hello. Thank you, Chadi. Round of applause.
Thank you.
Okay, we now have a break until 11, where talks will resume. In here at 11 o'clock, we have AI demand forecasting at ASOS.